I'm going to talk about the focus of our course, Mastering Python for Beginners in Data Science. So let me explain what kind of areas in this particular course we are focusing the most. In fact, because this is a course for beginners, that's a beginner level course, we are not assuming the course taker to have any experience whatsoever about any computer programming language before, not even the problem solving paradigm that lies in computer science. So we will focus on problem solving for a bit, and we will actually start from the very beginning what problem solving is, particularly in computer science. The second focus of this particular course is mainly telling you why we are choosing Python, why Python is so important, particularly for data science problems. The third focus and the main core focus is to learn Python, obviously. Once we know what are the techniques to solve a problem, and once we know that the Python might be a very good language to go with, then what is Python? How to learn it? Well, the Python is the main core and main focus of this course. Obviously, we will start from the very beginning, very beginning, which means we will start from how to install Python. For example, we will start from there. And then we will see what are variables. I mean, very beginning. And then progressively, we will be moving on and on and on to data structures, to complex structures. But that transition from 0 to onwards, that transition will be very smooth. I mean, whatever you know so far in the course, that will be helping you to gain more complex structures very easily, gaining the understanding of a lot of structures very easily. So in this Python, we will include all concepts of Python in general. And one more thing. After learning this Python, the way we organize this course, after learning this Python, you will be having understanding of other languages as well. I mean, the contents here are explained in so general way, although with the Python syntax, but the concepts are expressed in so general way. The problems that we pick to solve for practice are so generic that you will, after this particular Python course, you will be having understanding of programming languages in general. So data science is one other focus of this course. Actually, the whole course is organized in a way that it teaches you about Python, it teaches you problem solving, it teaches you something about overall programming languages and how computer can be used to achieve the solution of different problems, and using Python, of course. And then we will be introducing the data science packages that are available in Python, because they are really fast, really fundamental, very easy to use, and very powerful to handle large amount of data very quickly for data understanding, for visualization, for cleaning, processing, and a lot of stuff. What we are not focusing at, because that's important, knowing that what kind of things are the things that we're not covering. For example, we are not covering OOP, object-oriented programming. We are not covering exception handling. We're not doing web development or any general kind of tasks that are doable in Python. We are not focusing on those things. Everybody solves different problems every day. Some problems are easy to solve and some are difficult. And yet some are impossible to solve. They are called unsolvable problems. But think about different instances of the same problem one needs to solve again and again. For example, sorting the sale records. And let's say we are sorting the sale records with respect to the sale value, and we have to do it after every 8 hours. If the number of instances, if that number is huge, the optimal choice is to automate the solution, if the automation is possible. But how? How to come up with the automated solution? To come up with a general solution that works for every instance of some problem, that is one thing. But to get that solution running on a computer is yet another thing. problem solving deals with formalizing a general solution that works for every instance. And programming languages like Python deals with the running of that solution on a computer. Python, as we will see, makes the transition from problem solving to the running solution much easier and quicker. And that's one big plus of Python. A lot of words. I know, a lot of words. Let me take an example to clarify what I said. Hold on till the end of this video, and I will make everything what I said so far crystal clear. So let's take an example. Let's dive into an example to see what I just said. Let's say you are A and your friend is B. And your friend B is always willing to help you. Let's say you found such a friend. And then A just said, I want off just for some days, but B said, but what? Go buddy, enjoy. A said, someone have to do my job in my absence. And then B said, that's it? Is that your problem? I'm available, as always. Go buddy, enjoy. Then A said, great, you're a true friend. Okay, I'm leaving. Wow. Then B just said, hey, wait, what do I have to do? What's your job? At the end of the day, I'm going to do your job. What's your job? What do you do? And then A said, after every 8 hours, pick the email of the customer with maximum sales. So that's what you have to do. B said, okay, but from where? I mean, I have to pick that email of the customer from where? Where are the records? A said, oh, there are sales records. I mean, at the job place, there are sales records. And you have to pick the email of the customer with maximum sales. B said, oh, okay. But wait, what should I do with the email that I just picked? Then A said, oh, there is another record called priority records. Just write that email after 8 hours. Just write that email in priority records. And then B said, that's it. That's all your job. And A said, after so relaxed, A said, yes, that's my job. That's all. Now think, A leaves and later that day receives a call from B. And B said, I don't really know what to do. Can you tell me step by step what to do? Focus on again. I'm reading this particular sentence again. Can you tell me step by step what to do? I have sales records with me, having all the records for the last 8 hours. What to do? I just messed everything up. I don't know what to do. And then at the call, A just described a procedure to B for his job. That procedure or a general solution. Let's see the solution. A said, number 1, start from the first record. There may be several columns of the record: the customer name, the customer phone number, the customer email, the customer products that he bought, and the total sales. And the point 1 said, A said, start from the first record and focus just on the sales column. Okay, then after that, go to each next record one by one and find the record with the maximum sales. Obviously, once you have focused on the sales column, you're just comparing sales of different records with each other and will eventually come up with a record that have maximum sales. Number 3, if there are more than one records with maximum sales, it is possible that the maximum sale value, let's say, is 100, whatever the units are, and there may be 2 or 3 or maybe 5 records with the maximum sales, 100. Then which one to pick? A just described here in step 3 that if there are more than one records with maximum sales, then pick the first one from top to bottom and ignore the rest.
I mean, whichever is the, so let's say you have 5 records with maximum sale value. Which record appears first from top to down? Just pick that one and ignore the rest. That might be a policy. That might be a tie-breaking policy, but just do that. And then the 4th step is focus on the email column of the record you found in step 3. In step 3, you found a column with maximum sales. Step 5, see the email address and write that address in the priority records. So that's for the 8 hours. Then repeat this, see the step 6, then repeat this procedure after every 8 hours. I mean, repeat this procedure. I mean, you see the solution A is communicating to B in these kind of steps. It gives a precise idea of what to do. Still, there may be some questions that B is maybe asking. For example, B may ask how to find out a maximum. B might be that person who don't know how to find out the maximum. And third, for example, another question B may ask is that when I'm going to write the email address in the priority records, where should I write? At the very top or at the end or somewhere? But at the end of the day, a solution, a step-by-step solution is required for communication. This kind, if you see the solution, although it has some, it may be explained there may be more steps that should be added, but if you see the solution, this step-by-step solution, this is general solution. This is general solution, much more general solution for every instance. By every instance, I mean after every 8 hours, you'll be having some records and you have to do this procedure on the records for that 8 hours. And then after that 8 hours, you will be having more records to work on. So after every 8 hours, you have the same, the problem is the same, but the instance is different because the records after 8 hours are different. But the solution says whatever the instance you are right now, whatever the instance is that you're in, just perform these steps. A step-by-step solution, coming up with a step-by-step solution, is one module of the problem solving, and this step-by-step solution is called algorithm. Obviously, this step-by-step solution is not always required to be communicated in plain English or in natural language. You may come up with shorthands or shortcuts to explain these step-by-step solution. So the more shortcuts, the more precise and unique meaning keywords you use in your step-by-step solution, the more better communication of your solution takes place. And going from this step-by-step solution, which is just in plain English, going from this to a more concise and unique kind of procedure, that one step that will take us from there to there, that we will see in the next video, will be called a pseudocode. And from that pseudocode, there will be a few steps that will take us to the second major problem that the problem languages will solve, the get the solution running on a computer. So just in this video, I wanted to explain you that solving a problem may not be that hard. I mean, coming up with a solution of a problem may not be that hard, but communicating that solution or writing that solution in a form of procedure that can solve every instance of that problem, that requires a step-by-step treatment of the procedure, and those steps, they should be linked in a sequence and they should be unambiguous. And if a particular step requires more elaboration, that step might be broken down to further steps. But that step-by-step solution at the end of the day is called algorithm. Now, that algorithm might be in English, but we will see in the later video that there are better ways of expressing algorithms better than English or better than natural languages. So, so if you have another problem, come up with a step-by-step solution of that. Every instance of that problem should be solved by that step-by-step solution, which is called algorithm. And in the next video, we will see how to actually eliminate the need of having English with us, and how to incorporate the uniqueness of understanding of these steps or algorithm using the concepts of pseudocode. And after the pseudocodes, we will see it will be very quick to jump to any programming language, and we will see that the Python is very close to what humans generally think. I mean, it's very easy. The transition will be very, very easy. So hope to see you in the next video, and I'll be explaining algorithms in a more kind of keyword way, and in the same video we'll be focusing on pseudocodes, which are basically a pre-step of the actual code of in any programming language. So hope to see you in the next video. Okay, in the last video we were talking about the algorithm, what an algorithm is, and how to express that any algorithm. And we saw that algorithm is just a step-by-step procedure, but how to express an algorithm may vary. I mean, you need not always to have plain English or any natural language to express algorithm. The reason is that the natural languages are normally so expressive, and each and every sentence, they may have multiple meaning. So it is a good idea to come up with a structured way to express an algorithm such that each and every statement is completely unambiguous. And one such way is to express algorithms using flowcharts. Flowcharts are graphical ways of expressing algorithms. Here we are taking the problem here we are discussing is computing pay of different employees of some company. And the procedure of, I mean, if there are several employees, let's say employee 1, employee 2, employee 3, and so on. Let's say there are several employees in a company, and having each employee has name, phone number, email, and all the credentials. And then let's say the pay is computed on hourly basis, and each employee has worked certain hours, for example 8 hours, and each employee has an hourly rate, might be, let's say 100 units, whatever the units are. Employee 2 might have worked, for example 7 hours, but the hourly rate of this employee might be 200. Different employees, they might have worked for different number of hours, and each employee can have a different hourly rate depending upon the capacity of the employee or the job nature the employee is doing, and so on. So so if we want to compute pay of all the employees one by one, the procedure of computing pay stays the same. The instances, they differ. For employee 1, the value of hour is 8, the value of rate is 100. For employee 2, the procedure will stay the same. The values of hour and rate, they will differ. So what should be the procedure? The procedure might be that you take the input of, let's say, employee 1, or whatever employee you are going to compute salary for, take the hours value, in a placeholder, call that placeholder as hours, placeholder or a variable. Why this is called a variable? Because for different employees this value will be different. Hours will take value 8 for E1, employee 1. This variable, this placeholder, will take value 7 for employee 2, and so on. Similarly, once whatever employee for which you are going to compute the pay, if you have taken the hours from some records, from some working records, then take the rate for the same employee as well. So input this, that's step 1. Input 2, that is step 2. The sequence of these two steps may change. For example, you take the rate value first and the hours value later than that. But either way, that's one way of expressing this procedure. And then you compute the pay by this formula. So hours multiplied by rate. So maybe this is confusing, writing a star. Maybe we should write this cross symbol because that is more common in mathematics. Or maybe this whole line can be replaced by this particular line, maybe. So pay is equal to multiply hours and rate. Maybe this is more expressive, but it completely depends. I mean, when you start writing pseudocode or whatever pseudocodes you're writing, what kind of keywords, begin is a keyword, end is a keyword, what kind of keywords you're using, and stay with those keywords. For example, if the keyword input is to use to take to get the values to process on, then input should stay everywhere wherever we want to do such kind of operation. If you're using, for example, the value get rather than input, then use get always. But come up with some set of keywords that are expressive as well as concise, and then take the sequence of those statements. Each and every statement should have a unique meaning. It should not be ambiguous, and the sequence should be the sequence describe the flow of what is happening, what is going on. So first we take hours, then we take rate, these two values for any kind of employee, and then we will just multiply them. And after multiplication, whatever decision we want to make based on this pay, we will do that. We may record this value, this pay value at some other records register. We may print that value on a print slip. We may have emailed this value to some other department, whatever decision we want to make. But the procedure really is still here. Then based on pay, whatever action we are going to do, that may differ. Similarly, if we go, this is I mean some kind of structured example of the expressiveness of an algorithm, which is called a pseudocode. And what kind of keywords you're going to use? There are no general keywords. I mean, some people may use get, some people may use a different kind of keywords for it. But it is good to come up with a set of keywords to describe the solution of the problem. In flowchart, for example, every statement here that is here in pseudocode, every statement is described as a shape. Different shapes for different kind of statements. If you want to take input, then you have to describe that action using a parallelogram. If you're going to do some computation, you have to express that using a rectangle. The start symbol and end symbol, the start and end of any procedure in flowcharts, they are described by the ovals. For example, this oval and that oval. Normally the flowchart sequence is from top to down, but it is always good to just print the arrows to describe the flow, because in complicated flowcharts there are loops, there are if conditions, there are so many things. So it is good always to describe the flow using arrows. So now the question is flowchart or pseudocode, because flowchart also looks like very cool way of writing, expressing an algorithm, and pseudocode is also a way of expressing an algorithm. Well, converting flowchart to actual programming code is somewhat tedious. Writing a pseudocode beforehand, which is readable, which is precise, concise, as well as unambiguous, then converting that pseudocode to code of any programming language, that is not that hard, that is simple. And writing flowcharts for very complicated problems is somewhat tedious, because then it also requires another transition from flowchart to the actual programming code. That's why writing pseudocode is more feasible if the goal eventually is to convert that pseudocode to some code of programming language. So you can go with flowchart, you can go with pseudocode, either one is fine, but more feasible way of expressing algorithms is pseudocode. That was just a very simple example. I mean, computing salary of an employee, writing a procedure for that. I mean, this is so simple, nobody may care writing that kind of writing solution of this kind of problem as an algorithm or as a pseudocode or as a flowchart. But the basic idea is the same. Even if you have a complicated problem, even if you have a problem with maybe many more steps, the idea is still the same. In the next video, we will see a procedure how to make tea, for example. That may look to you funny. I mean, do we really want to know the procedure to make tea? Well, the idea is not to learn how to make tea. The idea is to learn how to express the solution of this problem. Making tea, that's a problem. The solution of this, how to express solution of that problem as a pseudocode, and we will see one more example of flowchart as well. So hope to see you in the next video. Okay, in the last video we saw flowcharts and pseudocode. We just took an example of we took a very simple example computing salary or pay of employee of a company given hours and rate. And I also described whether the comparison between flowchart and pseudocode, and I said that pseudocode is closer to the code of some programming language, which eventually we need, because eventually we need automation of a solution of a problem, and for that we need a code of the code for the solution, the general solution, in some programming language. So flowchart and pseudocode, and then the code of some programming language like Python. It is somehow and sometimes handy to break the problem or to devise the general solution of any problem in first step in a flowchart, because that is more expressive and more generic, more general, maybe in a graphical way. And then once the proof of concept is clear, once it is clear that this is indeed a general solution, it has no bugs inside, it has no errors, it will work always, then we can take another step to convert that flowchart to pseudocode, and then pseudocode can be converted to the code in some programming language. But writing pseudocode right away, I mean from the very beginning without flowcharts, is also a common practice. Either way, whichever way suits you. In this particular video, I'm going to talk about a problem. The problem is making tea. You might be thinking, what are the different instances of this problem? I mean, making tea is making tea. What kind of different instances are there? Well, one person may be liking tea with, for example, 1.5 units of sugar, whatever the units are. And another person may want a tea with, let's say, 2 units of sugar. One person may be needing a tea with, for example, 0.5 units of milk. And another one may be a different units of milk, and so on. So the procedure of making tea should stay same. And the instances, which means the different people want tea in a different kind of combination, that may vary. So let's see a procedure first in flowchart and then in pseudocode for making a tea, for making tea. So let's start. That might look to you a kind of funny kind of problem, but that's a genuine problem. For example, if you want to make tea, what is algorithm for this? So first we start, and then the first step we do is we put tea bag in a cup. That might be a first step. You can argue, should this be a first step? Should that be the second step, and so on? The sequence of, by the way, solving one problem, you can have multiple algorithms for that. And 2 different algorithms may just vary because of the sequence of statements, even if you have the same statements. So I'm not talking about that the algorithm or the general solution is unique. You can have multiple different general solutions or procedures. So for example, putting a tea bag in a cup, that might be first step, or the first step might be to boil the water and pour the water in the cup and then put the tea bag. Both are fine, I mean this way or that way. So let's start with putting a tea bag in a cup. So that's an input. We take a tea bag from somewhere, that's our input. Last time I told you that input is taken as parallelograms. Put a tea bag in a cup and then forget about that cup and boil the water. Somewhere there is a water. I mean, take the water from somewhere and boil it. And see if after, let's say, 5 or 6 or 7 time units, whatever the time units are, see if the water is boiled or not. Assume that there is a test that tells you that the water is boiled or not. So there is a test available to you. So you apply that test and check that the water is boiled or not. If it is not boiled, then keep on boiling. So boil it again. And assume there is a procedure of boiling a water. In normal case, boiling water is just happen by, keeping the temperature high or putting the pot of water on fire or something like so. But that itself is a procedure. So boil the water again and boil the water again. Check if the water is boiled. If no, then boil it again. If boil again, then check. If no, then boil it again. This is called a loop. This is called a loop or repetition. You are doing the same kind of stuff again and again until there is a particular condition that is met. So in this case, the condition is while the water is not boiled, keep on doing the same procedure again and again. This is called repetition or loop. So you boil the water again, check the condition. If the condition is true, for example, the water boiled, yes, then come out. Then you can exit this loop and come out. Then pour the water in the cup. Here we should describe that. Is that the same cup or a different cup? Well, this CUP cup here is acting as a placeholder where this tea bag and the water is going in. So we have a cup, we put tea bag in it, then we put the boiled water in it. But before pouring the boiled water in it, we just boiled the water. Okay, then after we have water in a cup and a tea bag in a cup, what should we do next? We actually we actually first test, want sugar or need more sugar? If yes, then add sugar. So let's apply some arrows. If yes, add sugar, and then again ask, do you need more sugar? Want sugar now? Yes, add sugar. Want sugar? Yes, add sugar. That is again a loop. While you want sugar, you test that the sugar is okay or not. Here you test that the sugar is okay or not, or whatever sugar you need, is that okay or not. Until that condition is not met, you keep on adding the sugar. Add a teaspoon again, then test, add a teaspoon. That is again a loop or repetition. Once the condition is met, want sugar? No. Then exit this loop and ask, want milk? Because some people just take tea without milk. Maybe somebody wants a milk, maybe somebody don't. So want milk? Yes. So add milk. So that's a mistake. This loop should go there, right there, and this line shouldn't be there. That's wrong. Add milk, and then ask, want milk? Yes. Add milk. That's again a loop. Once you exit the loop, then you ask, need to stir? Yes, stir. Then ask again. This line again shouldn't be there. So that's another loop. Once you exit this loop, then the tea is ready. You serve that tea, finish, you are done with the procedure. Now let's see the same procedure in pseudocode. Program is a keyword, and that's what program name is. Program make tea. Put is a keyword. Put tea bag in a cup. While water not boiled. While is a keyword. While this condition is not satisfied, keep on doing this. Whatever written in while and end while is the body of this repetition or called loop. So while water is not boiled, boil water. Then again check, water boiled or not? No, boil again. Keep on boiling. So this is repetition. Once the water is boiled, which means this condition becomes false. Water not boiled becomes false. So water boiled. Then you exit this loop. You pour that water in cup. That's again a keyword. You in a cup, and then you ask, okay, need sugar? Yes, add sugar. Need sugar? Yes, add sugar. So you keep on doing this until you don't need sugar anymore. So that's again a loop. So you might be thinking that why we are writing this add sugar and this boil water to writer to this why we are really indenting this. That's a style of pseudocode to just display that this is inside this particular statement or set of statements are called the body of the loop. And this end while should be here in this alignment. So there is a bug in this slide. This should be here. Okay, once this condition is false, sugar needed? No. Then you can exit this loop and you go here. While milk needed? Yes, add milk. Check again. Milk needed? Yes, add milk. Milk needed? Yes, add milk. Once this condition becomes false, milk needed? No. Then you can exit this loop. You can just go to here. While need to steer? Steer T. Need to steer? Yes, steer T. Need to steer? Yes, steer T. Once this condition is false, get out and your T is ready. Do whatever you want to do. This example was so simple, but it expresses a very powerful tool in the pseudocode as well as in flowcharts. And that tool is sometimes called loop, which is there to repeat a particular procedure, whatever procedure you want to repeat again and again until there is a particular condition that is met. That is loop is there. So the purpose of this slide was just to make you convinced and make you comfortable with this pseudocode and flowchart. We will not be talking about flowcharts any further from here on. We will be just talking about pseudocode in just one or two more videos, and then we will be directly going towards we will be comfortable enough with pseudocode for solving certain kind of problems that we will then eventually be moving from pseudocode to actual Python code. And I bet you I'm going to tell you that the pseudocode in the next video I'm going to explain that will be very, very easily will be converted to the actual exact Python code. So in the next video, we are going to actually solve a problem of finding out minimum value from a list of values, sometimes called the searching problem. We're going to solve it by first using pseudocode, and then in a later video, we will see how to write the actual Python code for that problem. So hope to see you in the next video. Okay, let's dive into a real problem. Let's say you are given a list of numbers. Let's say L is some list with numbers. Let's say we define list by these square brackets. Let's say the list contains 23. Let's say that's a value -4. That's a value 0. That's a value 73. That's a value, and maybe -10. That's a value, maybe 13. That's a value. So let's just take an example that we have 1, 2, 3, 4, 5, 6 values in a list. So and the list is basically we took the list here as L, and we just described that. Let's say the list is declared by or expressed by these square brackets, and the elements of the list, they are separated by comma. That is just our convention for this kind of problem, just for this code. And I'm not talking about any particular programming language yet. This is just a list of numbers. And let's say we want a procedure that finds out the minimum value of any list. Well, first of all, why this problem has multiple instances? Well, we need to come up with a solution that works for any list. For example, if the list has these 6 values, then the procedure should find out the minimum value in this list. The minimum value in this list out of all the values is minus 10, because minus 10 is smaller than every other value. 23 is bigger, minus 4 is smaller than 23, 0 is bigger than minus 4, because the value with negative sign, it is smaller with the value of a positive sign. But if you have two values with negative signs, the value with a bigger number in terms of magnitude is actually smaller in negative sense. So if you compare minus 4 and minus 10 is smaller in minus domain. In positive domain, the result is different. So I was talking about why this problem has multiple instances, why you need a general solution for that. That's a list. Just go and find out the minimum. That is minus 10. Go home happy. Well, we need a solution that works for another list with different numbers, and maybe different number of numbers. Maybe in this list we have 6 numbers. Another list may have 74 numbers. Another list may have 1 trillion numbers. We want to come up with a procedure that always finds out the minimum value in that list. Obviously, the minimum value may repeat. The minimum value may occur more than once in a list. So what is a minimum value? Rather than knowing how many times it occurs, what is a minimum value? That's a problem, finding out a minimum value. And we want to come up with a procedure that finds out the minimum value regardless of the list. Whatever the list is, this procedure should actually return or end up finding out the minimum value. So in this particular case, again, for this particular example, the minimum value is minus 10, and we will take an example of this list and we will see how to code a procedure for that. So, but before starting this procedure, what kind of things we really need to write a pseudocode for this kind of problem? We may start by writing that program, like in the previous video, program name as search, and then we take input or input list, then we take input the number of values in the list, the total number of values, and then we move on as we want to move on. But writing out a procedure in terms of pseudocode, it is always good to avoid these input statements inside the pseudocode, and always supply whatever needed. Always supply the instance from outside and assume that the instance is supplied, and then just work on that instance. Rather than reading the instance, rather than taking the values of instance, a particular instance from inside the code, it is always a good practice to supply the instance from outside. So supply the list from somewhere, and this n is really the size of the list. In this particular case, let's say if this is the list, then that list will be there, supplied from somewhere. We will see how to supply that. And this n value here, in this particular case, the n value is 6, the total number of values in the list. 1, 2, 3, 4, 5, and 6. These are 6 values. So it is a good practice to, rather than writing program and then this, just write the name of the problem you are going to solve. In this particular case, the name is search minimum from list. And then this particular, we are talking about this list L with total number of elements as n. Whatever the values inside the L is, we do not know. And this n may take a different value. This L can be different, this n can be different for different instances. But it is not a good practice to take input from inside here. Then one more convention is that, let's say list of 2 represents the second element in the list. In this particular case, L of 2 is basically the second element in the list, which is minus 4. L of, let's say, 3 is the third element in this list, which is 0, and so on. So let's take a convention that whenever we want to access the elements of the lists, but whenever we want to read the elements from the list, we will read the element number by giving the element number here. Let's say if we write L of I, that means it means the ith element of the list. So first we take a variable. We are assuming here that the list is supplied to us, the total number of elements in the list is supplied to us. So we first take the minimum value, which we really want to compute, the minimum value we want to compute. But any list can be supplied in this procedure. So what's the procedure? The minimum value that we want to compute, we just consider the very first value of the list. In this case, the very first value is 23. We consider that is the minimum value. Obviously that is wrong. This is not minimum value. Minimum value may be somewhere else, or maybe this one may be somewhere else, but we are not sure that the first value in the list is the minimum value. But let's just hold on for a moment and move on. Let's say the minimum value is this. Here, this is called the assignment. This min value is a placeholder or a variable, and I have assigned this value L1 to it. Now, from here onwards, the min value will be having a value which is 23 in this particular case. Okay, so min value is this, which is 23 now. Let's declare another variable which is called counter. We may need this counter, and let's declare this with 2. Why we are declaring this with 2, it will become clear later on. So now so min value right now for this particular list, the min value takes the value 23, and counter takes the value 2. These are two things for these two variables. Now we apply a loop while counter is smaller than n, smaller or equal to n. Remember, the value of n for this particular example is 6, and counter here is 2. So because counter has value 2, while 2 is less or equal to 6. First check whether this condition is true or false, because if this condition is true, then you will go to the body of the loop. Then this whole box will execute. If this condition becomes false, then you will exit the loop and will go out. So now counter is 2, so 2 is smaller or equal to 6. True, false? That is true. So the condition is true. 2 is indeed smaller than or equal to 6. That is true. So we will go inside to the box and see what happens. Then what we will do, we will pick a value from at the index counter. Right now the counter has value 2. L of counter means pick the value, because the counter has value 2, pick the second value, which is -4, and pick that value -4 from the list. Pick that value and copy that value or assign that value to a variable v. That's a new variable v, maybe needed somewhere. Okay, previously the min value, which is a variable, it was containing the very first value, which is 23. Now we have picked the second value, the counter value is 2, so we have picked the second value from the list, which is -4. Now we compare. If the value now, which is -4, is that value smaller than our minimum value so far? The minimum value so far is 23. So -4 is smaller than 23. Yes, the condition is true. If the condition is true, we will go into this block. Otherwise, we will go into this block. So right now the condition is true. So we will go in this block, and minimum value will just be replaced by the new value. And the new value right now is -4. So because -4 is smaller than 23, so we are here in this body. The if condition becomes true, we are in this body, and the minimum value becomes whatever the value is in v. And right, for this example, the value in v is -4. Okay, so if you go into the if condition, then you're not going into the else part. Either you're going to if part or in the else part, one of them. Okay, so then we move back. Oh, there's a bug here. We need to add the counter. We need to increment the counter here. After this, before this, there is another statement, increment the counter. Increment counter. That's another statement, increment counter. So now increment the counter after this if part, increment the counter, and the counter will become 3. Now we will repeat the procedure and check 3 is smaller than 6. Yes, we will go inside and we will pick, now the counter value is 3. We will go and pick the third entry, and now the third entry will be in V. The V will now contain 0. Previously it contained -4, now it will contain 0. Min value is containing -4 now. So 0 is smaller than -4? No. If 0 is smaller than -4, then do this. But 0 is not smaller than -4. Then go to the else part. And else part is just saying, just go on, do nothing. I mean, don't do anything. So when you're here, don't do anything, exit if condition, increment the counter again. Now you increment the counter value will become 4, and the value at 4 is 73. First of all, check 4 is smaller or equal to 6. Yes, V will contain the value at index 4, which is 73. 73 is smaller than -4. No, do nothing, increment the counter, check the while condition. Now counter will be 5. 5 is smaller or equal to 6. Yes, pick the fifth entry because counter is fifth. The fifth entry is -10. -10 is smaller than -4. Yes, okay. Replace min value with the new value. Now the min value will contain -10. Okay, because if has executed, else will not execute. You exit the if condition and then you increment the counter. The counter will become 6. Now 6 is smaller or equal to 6. Yes, because 6 is equal to 6, hence the condition is true. Now you go and pick the sixth entry, which is 13. Check 13 is smaller than -10 because min value is containing -10 so far. No, that is false. Go to else condition, go to else part, just go on, do nothing, increment the counter. Now the counter will become 7. And you go back and check the condition. 7 is smaller or equal to 6. False. Exit the loop. Okay, exit the loop, go to this condition, go to this statement now. Now you're out of the loop and return the min value. And see, the min value here is containing the actual min value, which is -10. So that's how we search the minimum. This return is also a keyword. So which means if we just use that function, if we just use that pseudocode with if we just use that pseudocode for this different kind of lists with its sizes, whatever the list, this was just one example. If we change the list, the procedure will work. One bug in the code was the increment counter statement was not there. It should be there after this end if and before this end while here. So that was a pseudocode of searching minimum. In the next video, we are going to use this pseudocode, and we will see how to rearrange the values of a list or sort the values of a list such that all the values that are smaller, they become earlier than the bigger values. And the problem is called sorting. So in the next video, we are going to talk about one more problem, very famous problem called the sorting problem. And after that problem, we will be going towards Python, because after that problem, you'll be having a fairly good idea how to solve a problem, how to write a pseudocode for a problem. And the way we are writing the pseudocode is very close to the actual Python code, which will become so clear to you. So hope to see you in the next video. Okay, in the last video, we talked about this, how to find out the minimum value from a list of values. And we came up with an algorithm with name search min from list. Here we have just made a little modification that rather than just returning the minimum value, we are also returning the position of the minimum value in the list. So for example, if the list is 17024, let's say, in 9, let's say that's our list. There are 7 numbers in the list. The minimum value is 0, so the minimum value itself is 0, but that appears in position 3. So when this procedure will end, the min value will contain 0, and the IDX, which is the position at which the minimum value was achieved, that will contain 3. So not only we are finding out the minimum value, but also we are finding out the position of the minimum value. This procedure or pseudocode actually describes a very simple concept. You consider the very first value as the minimum value and the very first position as a position of the minimum value, and then traverse the list element by element and see if you find any value that is smaller than the minimum value so far. If that is found, then replace your minimum value with the new minimum value and update your position number, and then keep on moving till the end of the list. So that's what that's the concept behind this algorithm searching minimum from the list. And to traverse the list, we use this loop, while loop. So next we solve a problem called sorting problem, very famous problem in computer science. So the problem really is, let's say we have a list, let's say 1, 4, 0, 3, 5, and 7, let's say, and the sorted order, the ascending sorted order, is the order in which the list is presented, so that the minimum value occurs first, then the second minimum, then the third minimum, and so on. So the sorted order for this particular list will be this. So this is the result. This should be the result of the sorting procedure. So let's see how can we solve this problem. We name this algorithm as sort list, and sort list contains this L. In this particular case, the L is simply this, and this N is the size of the list. In this particular case, the size of the list is 6, so 6.